Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. If you haven't already, like and subscribe to get new episodes delivered to your inbox each week. I'm your host, Cary Gitter, Associate Editor at SME Media. In today's special episode, we're doing something a little different and showcasing 3 of our recent Executive Perspectives interviews in which SME Media speaks to top leaders and executives from the manufacturing industry who participate in the Executive Perspectives panels at SME's Rapid TCT and Manufacturing Technology Series events. The panelists share their experiences and insights about the current state of manufacturing, as well as the opportunities and challenges that lie ahead. The 3 interviews you're about to hear were recorded live on the show floor at Rapid TCT in downtown Detroit in April 2025. First up is Dr. Masahiko Mori, Group CEO of DMG Mori, who offers his take on the future of advanced manufacturing. With over 5 million aging machine tools in use worldwide, some of them 2 decades old, Dr. Mori outlines the urgent need for modernization through smart, integrated, and precise 5-axis and mill-turn technologies. Highlighting the role of robotics, digital twins, and additive manufacturing, he emphasizes process integration, workforce transformation, and the vital role of small and medium-sized enterprises in driving innovation.
People talking about advanced manufacturing, by our research, I know the number our installed machines from DMG Mori is about roughly 300,000 machines working as of today. And think about our market share in the past, and also check the numbers of the installed machines with Siemens, Fanuc, Mitsubishi, Heidenhain, Beckhoff, and so on. I believe that about 5 million machine tools are working in the globe. The problem or subject to solve is that the average vintage is over 20 years. This is the issue. So it is very important. How can we smartly replace those kind of very old 5 million machine tools into a real 21st century equipment? We have been working very hard developing and making the very reliable and precise 5-axis machines or mill-turn technologies in the last almost 20 years. In summarize, the first CNC machines, not CNC, but numerical control machines are developed by MIT with support of the American government in 50s. And the 60s, numerical control turning machines becoming popular. And 70s, turning machines becoming more and more popular by use of the computing technologies. And also vertical machining center is coming to the market. In the 80s and 90s, horizontal machining center becoming popular. And then the beginning of the 2000s, everybody is starting to developing 5-axis and mill-turn technologies. Now it is matured. So that it's a time for us to replace the very old special purpose machines by use of the very reliable, flexible, precise 5-axis machining or mill-turns. And that is our mission, to replace 5 million machines to 1 million machines to make a more process integration. Of course, like as this Rapid TCT exhibitions, we can see many rocket industries or space industries, aircraft, jet engines, or medical industries, or even some as a machine tool builder, I ask my engineer for newly developed machines, we have to use at least 1 or 2 additive made parts onto the machine tools. So in short, machine tools are not made thousands a month. But if you have a product, something like 10 units, 20 units, 100 units a month, that is a very good application for using the additive made parts. As I say that in the world at this moment, 5 million machine tools. And then for the one shift, at least 5 million people are working in the factory, in front of the machine tools. But most of the people just putting the raw material into the machines and taking out the machine parts from there. This can be replaced by robots. Yeah? And you want to think about the processing integrations, 5 machines into 1 machines. We have to fully utilize the computing technologies, digital twins, or phenomena between workpiece material and the cutting tools and so on. So we need more scientific approach to make a real programmer or scientist in front of the machines. We can work together, and the demand for SME type educational and also vocational trainings, and by use of the English is a common language for any manufacturing societies all over the world. So that my expectation for SME is huge. We can work together more. Yeah. Well, I love this industry. You know that I want to sell more machines, but we are enough for making something 5,000 machines, 6,000 machines. Of course, our machines are very, very expensive, over $1 million US average in the United States. But if we can make more precise, robust, and fast, quick machines, this will directly contribute to enhance the quality of the human beings. And so the cutting phenomenon makes chips and swabs and so on, that is not so clean, but the nature of this industry is very clean. So harder work by us makes better life for the entire, better quality of life of the human beings. This makes us drive to make more efficient and robust machines for our customers. You know, I was born as a second and third generation of the machine tool builder. So this is my family business. And also I have a very, very good friends and customers and colleagues in my company. And then working together with Americans or Germans, Japanese or Asians all over the world by doing or developing the same technology or enjoying the same technology, that makes us a very, it's a kind of a joy for me, for us, to work together with the new technologies for the better life. We have been doing a machine tool business over a century. And always, of course, we have a large customer, company like, GE or GM and whatever. But always 50% of our customers are less than 100 people. Majority is 30 to 50 people's family-owned company or some new startups. People are always talking about startups or venture. Is always something related with too much software or Silicon Valley type of things. But, most important ventures or small SMEs is, coming from the manufacturing field, and especially for this type of the CNC machinings or additive technologies. It's a quite good fit for very innovative, family-owned or young talent, or even the elder ones. Small things is not disadvantage. Sometimes you can move quicker and then also take a responsibility for the quality and commerce in a good balance. So I strongly believe we can be a very best partner for such kind of a small medium enterprise from until now and from now on for the future.
Toward the end there, Dr. Mori mentioned additive technologies as being a good fit for ambitious small to medium-sized businesses. Yoav Zeif, CEO of Stratasys, would certainly agree. In this next interview, Zeif's message comes through loud and clear. The future of manufacturing is additive and digital, and the two go hand in hand. Analyzing the state of additive manufacturing, he also discusses how the sector must evolve from innovation for innovation's sake to effective value delivery for customers. From profitable growth to sustainable solutions, Zeif believes that a spirit of win-win collaboration, not win-lose competition, will carry AM forward.
Being profitable as an AM player is crucial, and also for the entire industry. Profitability is a reflection of the value that you deliver to your customers. If you are not profitable, it means that you are not able either to deliver value or to capture the value. And then the industry as a whole is not sustainable. So for us, every innovation has to go also with profitability. And our goal is profitable growth. AM was initiated as a cool thing. So it's all about delivering the innovation without focusing on capturing the value of innovation. The most common example is the hearing aids. Hearing aids, many of them, if not most of them, are being printed today because you need to personalize the aid. However, we as an industry, we get few cents for every hearing aid that is being sold for hundreds of dollars or thousands of dollars. It is not sustainable. So we need to find the way to capture value. And there are ways to do it. Collaboration is key. Collaboration is key because our competitors are not our peers in the industry. Our main competitors are the traditional manufacturing methodologies, like CNC, for example. And we need to break into manufacturing by focusing and collaborating. So when you want to create this value for your customer, you need to find the way to collaborate in a way that share the value that we created. This is win-win. What happened in our mindset when we think that our peers are the main competitors, we are looking for the win-lose situation. How can I do better than my competitor versus creating value together to our customers? For example, combining software and hardware, or combining material or hardware, or making sure that we are sharing the same standards. If we created value and we'll be mature enough to share it, this is win-win. Because the competition is the traditional methodologies, we need to penetrate where we shine as additive solutions. I call it only additive can do it. And only additive can do it in areas where we need to deliver special geometries with special properties. Because of the technology, we know how to do it better. The second area is low volume, high mix manufacturing. We are simply better in terms of the economics. The third area is when we want to protect supply chains and to produce near the customer. The fourth one is to deliver more sustainable solution to companies that sustainability is part of their brand. And the fifth one is the whole personalization and mass customization that literally only additive can do it. I'm very optimistic. We are going through a cycle, which is a combination of a macro cycle, but also industry cycle. The macro environment is clear. There is a lot of pressure from the top of being more efficient, and the whole manufacturing sector is being challenged. But this is good for us because it makes us sharper. On the industry side, we were in a period of innovation, the cool period, we can call it. Now we are getting into the period of delivery. We need to deliver value, to stabilize the solution and to deliver value, accurate part, total cost of ownership, reliability, and enablement, making our customers successful. What excites me is when I meet my customers, I see in their eyes that they understand that the future is additive, the future is digital and additives goes together. The future of manufacturing is digital. The best way to manufacture in a digital way is additive.
Yoav Zeif clearly has a strong vision for the future of additive manufacturing and where it should be heading. But where has it been? AM has come a long way from early technical challenges to life-changing applications in industries like healthcare. In this last interview, Brigitte de Vet-Veithen, CEO of Materialise, looks back at the sector's 40-year journey and explains why now is the time to shift focus from prototyping to scaling for end-use parts. Like Zeif, she stresses the importance of collaboration over competition, as well as the role of software in simplifying workflows and reducing costs, and the need to address the major adoption barriers of complexity, cost, and skills.
I think we do need to realize that we've gone through, a whole journey of the adoption of additive, over time, and that we have actually made great progress in some of the applications that we're powering with additive. I gave the example of the medical industry, earlier today, and whether that's patient-specific devices or standard instrumentation or implants, we have been able to help multiple patients, millions of patients actually, with those devices. And that is something to be proud of. So the doom and gloom is certainly not justified, because we have been able to change industries in certain applications. And yes, there's more progress to be made, but it's not all bad. Well, our industry, the additive industry, which as such is not an industry, to be honest, is a very small industry. But the manufacturing market as such is a huge market. So we should concentrate our efforts on conquering that huge market rather than focusing on competing within our small market. And that's what collaboration is all about, using each other's capabilities to create a larger market rather than a small market. And that comes in many different forms and fashions. Here at Rapid, we are announcing the integration of Magix and NTOP as tools, which can help accelerate people and process really large files, implicit files, in a much faster time. So saving, going from days to seconds in processing these files. And that is because of the collaboration and the integration we achieved between our different tools. So that's just one example. So leveraging each other's strengths to create a larger market, help our customers find solutions, reduce the cost of parts, which is what it's all about. And that's why collaboration is so important. If we look at what our customers tell us, what keeps them from adopting additive for end-use parts, there's really three things that we got out of a recent survey that we did. They struggle with the complexity of adopting additive. We're making it really complicated for our customers still. They struggle with the cost. The cost of the part eventually needs to be at a level where it allows our customers to compete. And the third thing they struggle with is the competencies and the skills that they need to adopt additive. Now, those are the barriers that we need to break to accelerate adoption in end-use parts and get serious about scaling in additive. Now, what can be done to achieve that? Obviously, I'm a little biased, but software can play a huge role there, because how do you reduce the complexity? Well, rather than asking people today, as we do today, to upload and download files, let's create an ecosystem, a real digital thread where we transfer the data throughout, so that that data can also be used to then do smarter stuff on it to reduce the cost and the efficiencies throughout the process. So software can be a real enabler to bring down the cost, reduce the complexities. And with software, you can also build some of the intelligence you need for the adoption that you otherwise would expect from your skilled labor and your skilled workforce. You can build that into your systems. So again, software can help address all three barriers of the adoption that we face today. We've been, as an industry, in existence for about 40 years, I'd say. So let's look at that history in decades. I would argue that the first decades, we really spent our time and money on figuring out how to make the technology work. We had printers, but that didn't mean that necessarily parts came out of it. So making the technology work was about the first decade of this industry. We then got it to work and spent the second decade in the evolution on finding applications that are meaningful, where this technology could really make a meaningful difference. The medical application that I referred to earlier is one of these examples that we found at that point in time. Great match. We had that. Then we spent the third decade finding out how to make that valuable and how to make sure that people see the value, are willing to pay the value, and with that, build a business model for some companies that is sustainable and that we could all live off. So win-wins for all stakeholders. I would argue that now we're in that fourth decade where we have the technology that works, we have meaningful applications, we found ways to make that valuable, we now need to scale. And that scaling comes through the adoption of additive for end-use parts. Prototyping is a very well-known use case, but the real growth is going to come from these end-use parts. So I feel good and bad about Rapid and the state of the industry and the discussions here. On the one hand, it's great to meet all of our partners and talk about further collaboration, see what we can do together. On the other hand, it's the industry talking to the industry. So, it's good and bad at Rapid, but I'm really pleased to see the attendance being so high because, it's only with people being here that we can network, connect, and talk about collaboration to push the boundaries there.
Well, there you have it. 3 expert perspectives on the path that the industry must take going forward, from modernizing machine tools to scaling additive manufacturing. And a common thread emerges throughout. Active collaboration among key stakeholders has never been more important. Thank you for listening to today's episode. To keep up with the latest manufacturing trends and hear more episodes of our podcast, subscribe to our podcast feed and, of course, visit us at advancedmanufacturing.org.